It's now time to look at the other half of the transport layer communication, port numbers. In the previous video, we talked about the first half, which was TCP and UDP, making a choice of being reliable or unreliable. Now we need to talk about separating our TCP and UDP applications so that we can distinguish what service we're trying to access and what window on our PC or what service the server will be sending back to. Trust me, that'll make a lot more sense when we start looking at the port numbers. So we're going to look at how the port numbers work to separate those applications. Then we'll get into the well-known port numbers and things that you should know and be able to recognize as you're working in the network field. Every time an application communicates across the network, it must not only choose what kind of protocol it's going to use, as in TCP or UDP, but it also has to generate some port numbers, what destination port it would like to go to, and what source port it would like to come from. Now, we talked briefly about this when we originally talked about the OSI model, and I mentioned that we were going to cover this in depth a little bit later on, and here we are. It's later on. So let's say we have this host over here on the left-hand side, 10.1.1.10, communicating with the server 10.5.1.100 on the right-hand side. Let's just say he's got a web browser open, so he's using HTTP to access this. Well, HTTP uses a well-known port number of TCP, it's reliable, port 80. So when it sends a message over to the web server, that web server will receive it on TCP port 80. Now, the way it's actually designated, and you'll see it written plenty of times, is this host on the left sends a message to 10.5.1.100 colon 80. By combining the port number with the IP address, the technical term for what you have is a socket, meaning you have opened a socket or a session over with that server. This is the destination socket that I'm going to. Now, when that server receives it on port 80, it goes, oh, you're not looking for my email services or my SQL database services or any of the other services that I'm running. Since you're going to port 80, that is the well-known port number assigned to HTTP. As a matter of fact, I have a slide dedicated to well-known port numbers, but let me just jump a little ahead of my slide, and I'm on eBay. I want a wireless webcam. I was looking for one. But let me show you. This is actually, let me drag this down a little bit further here. IANA, that is the people that govern the IP addresses and also maintain what's known as well-known port numbers. They have right here a list of well-known port numbers that are assigned. And if you look down, you can see that we have some management utility called CompressNet uses TCP and UDP port 2. Port 3 is also used by the compression process. And as you scroll down here, you start seeing stuff that becomes recognizable. Like, for instance, we see port 21 is considered reserved for FTP. Scroll down some more and we see that port 22 is assigned to something known as SSH. We'll be going through a lot of these well-known port numbers, but if you look at this list, just look at that. This is all of the well-known port numbers or services that use these well-known port numbers that are out there. Right there we are. Port 80 uses TCP. You can see it's also known as www or www.http. It's just different ways of annotating the same thing, but they all use TCP port 80. And you also see that they've reserved UDP port 80 for that as well, if there's some application that decides it wants to communicate unreliably. Although I will tell you, 99% of the world uses TCP port 80. But I want to show you this. I'm moving over. Look at that. That's my scroll bar. Let me just grab that guy. You see how fast the things are scrolling over here on the left-hand side? I mean, just ports and ports and ports. And they have just about everything that is well known. I mean, look at this. I'm going to do a find. Let me shrink this down a little bit so you can see. I'm going to type in Warcraft. Enter. You can see that right there. World of Warcraft, Blizzard, WoW, uses TCP and UDP port 3724. So when people are playing the game World of Warcraft, their game is actually accessing that server on 3724. Now that server may be, somewhere out there, and it might be Blizzard. That's the people who make World of Warcraft. It might be their web server, and doing some other services for them as well. But when you come to that port number, that's how it knows what application you're trying to access. Now that's the destination port. The computer over here on the left-hand side also generates source ports because your computer, in a way, is like a server as well. It's running all kinds of applications at the same time. I'm looking at my taskbar at the bottom. I have one of those fancy Dell 30-inch monitors, so it's just huge. But still, my taskbar is filled with all of these different applications that I have running. You know, before I decided to talk to you, I was surfing for a wireless webcam that I want to get. I wanted to watch my baby when she's in the baby room sleeping, so I can pull her up on a web browser. You know, and I've got some PowerPoint files open. I've got some, I don't even know what some of these things are that I have open, but I'm sure if I opened them, I would start understanding. I have virus protection running. I have all kinds of things happening on this device, and all kinds of network communication is coming into it, and it needs to be able to separate those things. So, what we have is source port numbers that are generated to allow the return traffic. For example, when I go to a website, it's going to go to port 80, but it will open up some mystery dynamic port number for the return traffic. Now, that mystery dynamic port number is made up by Windows. Let me give you an example of how this works. Let me open a new web browser. I'll just go File, New Window. There we go. I've got my Firefox web browser that's opened up. Now, I just want to make sure you know that down here below on Firefox, I also have some plugins that are telling me the temperature right now. Yes, that is the real temperature right now here in my beautiful sunny state of Arizona, and I have all these fans blowing on me just to try and keep it cool in here. But that, I mean, that right there is creating a socket going out to some weather server that is telling what the weather is. I just went to the Firefox start page, and it's created some sessions there. I'm going to go to a couple websites. Let's go ahead and move this down a little bit. I'm going to type in www. Let's go to msn.com, the ultimate waste of time website. Or if you ever want to waste some life, there's plenty of it to be done right here. I'll also go to cbtnuggets.com. Bring up a session there. There we go. CBT Nuggets, win an Apple iPhone. You know, all of this stuff is being delivered. And let's go to one more, eBay.com. Just opening a couple sessions. There we go. So see, that's what I was just looking at, my wireless webcam. So I'm going to bring up a command prompt over here and type in the command netstat. And with Windows Vista, I have to follow it up with a -F, which gives the fully qualified domain name. Now, my computer is running up mini sessions. A lot of them are run between itself. I don't know if you remember from the IP address chapter, but we saw that 127.0.0.1, or anything starting with 127, is considered a loopback address, where it's actually looping back to himself. So it's communicating from itself to itself. By the way, my computer name is Jer Workstation. And it looks like it's kind of frozen right here. There it goes, starting to come along. The reason Windows goes so slow is it's trying to resolve what the names of these IP addresses are. And there's sometimes when they just don't go to any name, so it'll just kind of sit there and wait to wait for a name to come back. But they're not going to any names. Here, tell you what, I'll add another keyword onto there. We'll let that guy run in the background. But I'm going to type in netstat-n. Ah, there we go. That will actually, instead of trying to put like ebay.com and cbtnuggets.com, it puts the IP addresses of those websites up on the page. And that way it doesn't have to try and look up all those names. Now, but by the way, you can see it resolved msn.com behind the scenes. But if I look right here, scroll with me for a moment, I have the protocol over on the left-hand side. It shows TCP for all of this communication. Local address, that's me. Foreign address, that's the destination that I'm going to. Now, as I scroll down this list, let me just see if my named list is, there we go. That's a little cleaner because I like seeing the name here. If I look down here at the foreign list, I can see, for instance, cbtnuggets.com : remember I said that was our socket, HTTP, to let me know that I'm using port 80. Now, Windows does hide all of the ugly port 80 and just puts HTTP there, unless I put that little N. But what I want to show you is over here on the left-hand side. Look at that. 172.30.2.50, 51.891. That is my source port number. So when my computer sent to ebay.com or cbtnuggets.com, it came up with 51, whatever it was, 891, is that what it was? So it came from a source, if I was put that in socket format, 172.30.2.50 colon 51891, just like it showed on that command prompt. So it went from that source to this destination. When the web server comes back and transmits back to me, it will send to a destination of this socket right here. And that's how my computer knows what Internet Explorer window to put that information in. That's how it distinguishes between the different applications. And that's how the port numbers work. At any given time, by the way, that's a great way to find out if you have a virus on your computer, is go to a command prompt and do a netstat. Because the virus will always be opening sessions to communicate to the outside world. And if you ever see things, like for instance, when I was doing this to kind of prepare to record this, I saw this guy right here. I was like, whoa, what is that? Deploy akamatechnologies.com, and I never opened a web browser to go there. And sure enough, I opened a web browser and went there, and nothing's there. Immediately before I recorded this video, I was thinking, that's creeping me out because I know I'm not opening a session to that server. What is that? So I did a little research and come to find out that is actually the Windows Update Services that uses that server behind the scenes anytime it has some sort of update to use. But that is an example of how you can figure out when new sessions are coming from your computers. I encourage you, pause this video right now. Go to some websites, surf around. Don't even do that. Just open a command prompt, start, run CMD, and type in netstat. And just take a look at what sessions are coming from your computer. It's pretty awesome to be able to figure out what your computer is doing. Now that you've got the concept of what port numbers do, let's talk about the well-known port numbers. These are what I would consider the especially well-known ports, because you can see my note over in the lower right-hand corner. It says 0 through 1023. Like if I come up here to this port numbers list and scroll down through all these port numbers, all the way up to 1000, up here somewhere, right around here, 1023 is considered well-known port numbers. Anything after that, you can see, is considered registered port numbers or free-for-all port numbers that people can use. These port numbers, 0 through 1023, are considered reserved, meaning if I was to write an application, maybe I created my own online game, right? The Jeremy game. I could not use port numbers 0 through 1023 because they're reserved for other well-known services that I'm not able to touch. So I'd have to choose one of the other 65,000 port numbers. The other point I want to make is TCP and UDP have their own set of 65,530, I guess you could say 36, since it starts counting from 0, port numbers that are available. So for example, I might talk about a service like port 900 on TCP, and that may or may not be running the same service as port 900 on UDP. Maybe 900 TCP is for Jeremy's game, and 900 on UDP is for voice over IP features or something to that nature. So they run completely separate sets of ports. With that being said, these are the especially well-known port numbers. And when I say especially well-known, I mean port numbers that you are going to run into again and again and again in the networking industry. So much so, I would recommend committing this list to memory. Not sit there and do root memorization. Okay, 21 is FTP, 21 is FTP. You don't have to do that. I'm just saying that as you go through this series, you're going to start seeing these port numbers so many times, they should naturally embed themselves in your memory. Not just in this list format, but as we're doing tests and setting up connections and so on, we'll say, okay, we're going to use Telnet. Bing, in your mind should go off port 23, TCP. Those are the common applications. So let's just hit these real quick. TCP port 21 is considered FTP. That's file transfer protocol. It's used to send files back and forth on a server. Now SSH is port 22. That is an encrypted version of Telnet, meaning a system that we can use to manage our Cisco routers and switches, and people can't see what we're typing because it's all encrypted. Telnet, port 23, TCP, that's the well-known port number. That's clear text. It's kind of dangerous to use because there's no security, but very common way to manage Cisco devices. SMTP, that's the simple mail transfer protocol. That is for sending email. When mail servers send and receive email, that's what they use. DNS servers use port 53. And when I say DNS server, that's a server that resolves names to IP addresses. Like Microsoft.com becomes whatever IP address Microsoft.com has. That's the port number servers use when they want to send DNS records to each other. Port 80 is HTTP. Hopefully you've seen that one a couple times by now. Port 110 is POP3. That's the post office protocol. That one is used when you want to receive email, when you open your Outlook email client and download it from a server. HTTPS, finally TCP port 443. That's secure web surfing. Everything's encrypted. So TCP applications are far more common than UDP because most people want reliable communication for their services. The only two that I would recommend knowing off the top of your head for UDP is, again, port 53. That's a DNS client. That's when you at home go to yahoo.com and your computer says, what's Yahoo's IP address? It's going to use UDP port 53 to ask a server and figure it out. UDP port 69 is TFTP. That stands for the Trivial File Transfer Protocol. That is one that we can use to send and receive files to and from our Cisco devices. That's it, short and sweet, what port numbers are all about. So let's recap. We first looked at how port numbers work, and we looked at their function to separate the different applications on our network. The destination port numbers dictate what service you're trying to reach, and the source port numbers gives that service that you were trying to reach a way to communicate back with your PC, and your PC to be able to separate the applications on itself. We then looked at the well-known port numbers, which in a broad sense is 0 through 1023, and in a more streamlined sense was the list that we worked through, which were the extremely common network services that you encounter every single day. I hope this has been informative for you, and I'd like to thank you for viewing.